Hello everyone, myself Hans. Today we are going to solve the given problem based on Jacobians. Here in the question, use Jacobians to show that the function u is equal to 3x plus 2y minus of z and v is equal to x minus 2y plus z and w is equal to x bracket x plus 2y minus z are dependent of each other and find the relation between them. Let's solve the problem. Given u is equal to 3x plus 2y minus of z and v is equal to x minus of 2y plus z and w is equal to x into x plus 2y minus of z. And we have to find the Jacobians and which are also find the function u, v and w are dependent and find the relation between them. First we have to find the Jacobian, that is del of u comma v comma w upon del of x comma y comma z. We have to find this and also find the dependent and find the relation between them. Del of u comma v comma w upon del of x comma y comma z is given by, that is del of u comma v comma w upon del of x comma y comma z is given by determinant of del u upon del x, del v upon del x and del w upon del x. Further for y, that is del u upon del y, del v upon del y and del w upon del y. For z, that is del u upon del z and del v upon del z and del w upon del z. We have to find the value of del u upon del x and del u upon del y and del u upon del z and del v upon del x, and all of these we have to put in the given determinant. First we have to find del u upon del x. From u is equal to 3x plus 2y minus z, differentiating partially with respect to x, that is del u upon del x is equal to 3. Further we have to find del u upon del y, that is del u upon del y. Again the value of u differentiating partially with respect to y and 2y differentiating partially with respect to y, that is 2. Further we have to find del u upon del z. Again the value of u partially differentiating with respect to z, here is the minus of z differentiating partially with respect to z, that is minus of 1. Further we have to find del v upon del x. Del v upon del x. The value of v partially differentiating with respect to x, here is the x differentiating partially with respect to x, that is 1. And del v upon del y. Del v upon del y. Again the value of v partially differentiating with respect to y, here is minus of 2y, partially differentiating with respect to y, that is minus of 2. Further we have to find del v upon del z. Del v upon del z. Again the value of v partially differentiating with respect to z, here is the z partially differentiating with respect to z, that is 1. Further we have to find del w upon del x. Del w upon del x, that is the value of w partially differentiating with respect to x. Here we can also, the value of w is written as x square plus of 2xy and minus of xz, and the value of w partially differentiating with respect to x, that is 2x and 2xy, again differentiating partially with respect to x. Once again x plus 2y minus of z. del w upon del x, again value of w partially differentiating with respect to x, that is 2x plus of 2y and minus of z. Further we have to find del w upon del y, that is del w upon del y. The value of w partially differentiating with respect to y, here is 2xy differentiating partially with respect to y, that is 2x, and further we have to find del w upon del z, del w upon del z. Again the value of w partially differentiating with respect to z, that is minus of xz partially differentiating with respect to z, that is minus of x. Once again, x square plus 2xy minus of x, that del w upon del x, x plus 2y minus of z. We have to put the value in the given determinant, that is del u upon del x is 3 and del u upon del y is 2 and del u upon del z is minus of 1. Further we have to del v upon del x, that is 1, and del v upon del y, that is minus of 2, and del v upon del z, that is 1, and del w upon del x, that is 2 times 2x plus 2y minus of z, and del w upon del y, that is 2x, and del w upon del z, that is minus of x. This is R1 and this is R2 and this is R3 and this is C1, this is C2 and this is C3. Column 1, column 2, column 3. We have to take a common minus of 2 is taking common from C2. We have to write here taking common 2 from C2. Then that is 3 and taking common 2, that is 2 is taking common, then 3 here is 1 and here is minus of 1 and 1, and from C2 we have to take common 2, that is this is also minus of, once again, minus of 1 and 1, and this is 2x plus 2y minus of z, and from here we have to take common 2, that is 2, and from here is minus of x, sorry x, here is x. Taking C2 from 2 common, that is 3 2, 3 1 minus 1 and 1 minus 1 and 2x plus 2y minus of z and minus of 2. Once again, C2 common taking taking common minus of 2 from C2. Here we have to take common minus of C2 from minus of 2 from C2 column 2, that is this is minus 1 and this is plus 1 and this is minus, and here in the given determinant two columns, that is C1 and C2, if the two columns are identical and same, so we have to, the value of Jacobians is 0. Del of u comma v comma w upon del of x comma y comma z. In the given determinant, two columns are identical, so we have to put the determinant Jacobian is equal to 0, and further we have to solve, we can also get the 0. So we have in here two column C1 and C2 are identical, so the value of Jacobian is 0. We have to put the value of equal to 0, and from here we have to set the u, v, w are the dependent of each other. Further we have to find the value of, find the relation between them. Further we have to find the relation between them, because the del of u comma v comma w upon del of x comma y comma z is equal to 0, because here in two columns are identical, so the value of Jacobians is 0. Further we have to find the relation between them. Further we have to find relation between them, that is u is equal to 3x plus of 2y and minus of z, and v is equal to x minus of 2y plus of z, and w is equal to x into x plus 2y minus of z. We have to find the relation between them. We can also write that is u minus of v, that is 3x plus 2y minus of z, and minus v, that is minus of x plus of 2y and minus of z. From here we can write that is 3x and minus x, that is 2x, and 2y plus of 2y, that is 4y, and minus of z, that is minus of 2z. From here we have to take common 2, that is 2x plus 2y minus of z, u minus v is equal to. We have to find the relation between them. X plus 2y minus of z. Further we have to find u minus v, and we can also find that is u plus of v, that is 3x plus 2y and minus of z, and plus of x minus of 2y and plus of z. From here that is 3x plus x, that is 4x, and plus of 2y and minus of 2y is cancelled out, and minus of z and plus of z is also cancelled out. Then u plus v is equal to 4x, and let this is equation first and this is second. Multiplying equation first multiplied by equation second, we get multiply left hand side to left hand side and right hand side to right hand side, that is u minus of v and u plus of v is equal to 2 times of x plus 2y minus of z into the equation of 2 right hand side is 4x. From here, that is 4 to the 8x and x plus of 2y minus of z, and here we can also write that is u minus v and u plus v is written as u square minus of v square. We know the following identities, that is a square minus of v square is written as a minus of b and a plus of b. We use the following identity. Further we have to write that is u square minus of v square is equal to 8, and we have to put x into x plus 2y minus z is equal to w. Here is given w is equal to x into x plus 2y minus of z. So we have to put the value in place of w, that is required relation is u square minus v square is equal to 8w. Thank you class and thank you for watching.